Alright, Rory here with the FarmBot project. So this is a little update on the universal tool mount system. This is version 5 that we're looking at. For comparison, here was version 4. In the last video, I showed how we had added some features here. So we basically added, if we flip this over, a couple of barbs, and these printed out poorly on this version. These barbs here and here, 3 of them, one for water, one for vacuum air or pressurized air, and one for some type of liquid amendment. And so what that allows us to do is have a greater variety of tools, things, and we can integrate everything into one component, making the universal tool mount truly universal. So we can have a watering nozzle and some way to suck up, let's say, liquid fertilizers and mix it with the water, etc. So the similarities between these two designs are that there are still these 4 screws that act as the electrical connections. On this design, we had a magnet screwed in the center, and then we had these 3 screws around the periphery on springs. So those were, oh, they're not in there right now. Let's see if I can get the spring out. No, it's not going to come out right now. And on this design, we had the same thing, except we also had the center screw also on a spring, and that's because the idea was that the mechanical connection was going to come from the 3 magnets, and that was also going to create the seal between the tool mount and the tool in order for air and water to not leak through. And then there's also, we were going to have a little gasket potentially glued on there like that. So this posed several issues. One, it's really hard to get all these magnets to lie in here and be in the same Z level. This part printed out pretty poorly, but even with better printed parts, the Z level is not quite right, so it never really makes that great of a connection. So first off, the gasket is definitely required. We couldn't get away with just bare magnets. The second issue is that the magnets have to be glued in. And while that works fine, it's the difference between having a laptop where you can unscrew it and replace the screen and having a laptop where everything is glued together, and if you break your screen, well, it's a lot more involved to get the new screen in. Basically, at one point, we were putting these magnets in here, and we accidentally flipped one of them, so the polarity was wrong. And so then that required us to, basically Dremel out super glue and plastic and then pry out the magnet, and then we had to flip it and make sure that it was the right orientation. So it really wasn't an ideal system. The other issue is that the 3 magnets mating with the 3 magnets on the other side was actually way too strong of a connection. We really just need more distance between the magnets, if we're going to have 3 of them. And we want 3 of them because with a single magnet, it's much easier for a tool to get torqued out. It has great axial pull force, but not so great torque resistance. So we want 3 magnets, but they just can't be that strong. So they need to be a little bit farther apart. Let's see here. So the new version solves several of these issues. Let me pull it over here. So here it is in yellow. Let's get it to focus on here. So the new version is kind of a combination of these 2 versions. So this new version is going to have the magnets go these deep wells again, kind of like that, just like this version 4 design. And so that means that these are just going to be screwed in. We're going to use an M5 screw and put that in there. Get it in there right now. So we'll put that through and then just screw it in from the other side. This screw's not long enough, but we'll have some that are a little bit longer. So that allows us to easily remove the magnets in case we put them in backwards, or we want to replace them, or maybe we're retiring this piece of plastic and we want to still reuse the magnets. It'll be a lot easier to get them out. And so because each of those magnets will be screwed in, we're actually going to use those as electrical connections as well. So now that the magnetic holding power is not on the water liquid nutrient and air lines, it's on the electrical connections. And then we'll have in the center here basically like one of these, a screw on a spring. Now, if you look close here at these little nubs sticking up, these are 3D printed all in one piece, and you can see, if it will focus here, that they all have little, a little rib or a little indents right there, a slot, a channel, I don't know what to call it, and that is actually for an O-ring to fit on. So in this design, we'll take an O-ring and we'll slide it on here, and that actually fits on really quite nicely. These are, in this design, they're 7mm inner diameter by 2mm thickness O-rings, and so those actually fit on there quite nicely. And so what that does is this is the water, air, and liquid amendment lines. On the other side of those holes, we're going to take these stainless steel barbs that have threads on them, and we're actually just going to screw them right in the top there. What we found is that we can 3D print barbs. These ones printed very poorly, but we have gotten some successfully printed ones. Let's see. Here's a couple better ones over here, if it'll focus. But they're really not that great. It comes out better on a higher quality printer. But even so, they're susceptible to breaking because when you're pulling the tubing off or even putting it on, there's just a lot of force on it. So they're very susceptible to breaking, so we'd rather not use them if we can get away with it. Potentially, we're actually waiting on some higher quality printed parts, and maybe they'll be strong enough such that it's a better design to integrate it all into one piece. So we'll see. But for now, for this design, we have these little barbs that we're just going to screw right in there, and that will be nice and robust for us to attach the tubing to. So back on this other side, again, we'll have the 3 magnets on the edges here, and they'll be screwed in. So the screw heads will separate the magnet somewhat from the receiving magnets on the tool. And then in the center we have the 4th screw, and on these right here is the liquids and airs. And the way this works is here is a printed prototype seed injector. The way this works is this has the receiving little chamfers right here, countersinks, to accept these nubs. And then on the surface here, we're just going to screw in, not in the center one, but on these 3 outer ones, we'll just screw in magnets or washers. And the washers themselves, we can stack as many as we want in order to get the right pull force. So that's a pretty neat design because everything can be essentially easily interchanged out. There's no glue. And it seems to come down, if we can get a shot here, and make a pretty nice connection on there. There's only one O-ring on here right now, but you can see that it's the O-ring that is the first component that, let's see if we can focus, is the first component that sort of hits and makes a mechanical collision, and that's what we want so that we actually get that seal there. So that's a really neat design. So the magnets will essentially pull this whole receiving end down and connect up all the O-rings. I'm going to get the rest of these on here. So we're really excited about this. It's basically a combination of the best of this design and the best of this design. The best of this design is the triple magnet orientation plus the addition of course, the water, air, and liquid amendment lines. But it's the best of this version in that the magnets are sunk down and screwed in rather than glued in. So this will go right on there like that. So that makes a nice, good little connection there with all 3 of the liquid amendment lines. And then the seed tip, it would basically just be sucking up air through here, and so then a little seed will get stuck on the end, and then it can go over and deposit it and cut off the vacuum and then leave it in the ground. The other thing that was an issue with this design was the tool had also 3 magnets on it and also 3 screws, and so did this. This had the 3 screws on the outer side plus the one in the center, and then the 3 magnets. And the problem was that when they're coming to mate with each other, the magnets would sometimes not want to go onto each other, rather they would go onto the screws. And that's because the screw heads would maybe be extended up a little bit, or maybe it was just off by enough such that the magnets would then attract and it would basically not mate properly. Whereas with this design, the blue one, it pretty much goes in no matter what. There's only one magnet, and it's attracted to that one magnet, and it seems to work just fine. So in this design, we're gonna have the screws on this one side let me start over here. The screws and the magnets are all gonna be on the same holes. So over here, there's going to be a magnet and a screw, a magnet and a screw, a magnet and a screw. Rather than over here, it was magnet, screw, magnet, screw, magnet, screw. And so that means that it's always going to want to pull towards the metal. There's never going to be a chance where it wants to be off by 60 degrees. It's always going to want to go right on there. And it's very unlikely that it's going to be off by 120 degrees because that would require significant spin while this is being held in the tool mount. Or the tool bay. So we think that this is going to be pretty good. I'll end the video here, and then I'm going to assemble this thing and we'll give it a little test run. So I'll add a little bit more onto this video in a second here. So this is exactly what I was talking about. In the fact that it's a nice feature to be able to remove the magnets easily. So I put 3 in here. I thought I was being careful about the orientation of them, and I put 1 in here, and it turns out that, let's see, it will attract to one of the magnets on the receiving end, but it's repelling the other 2. So I already screwed up. So it's really nice that I'm just going to be able to unscrew these and screw them back in. But it is looking good so far. It does like to go on there quite nicely. It's a little bit off kilter because only one of the magnets is attracting. So once we get all of them, it will be nice and flat like that. Alright, moving on. Alright, so we just got the new version 6 universal tool mount assembled. We have the 3 magnets screwed in on the sides, nuts on the bottom. And we actually switched out the O-ring size. They're now 7mm inner diameter by 1.5mm thickness. They fit a little bit better. And then here is the V6 seed injector. So it basically just has this little tip right here that hooks up to a vacuum line. So you can see that that goes all the way through. And then we have these 3 magnets on here that will attract to the 3 magnets on there. These little countersinks right here will go into the divots right here, and that's where the O-ring makes the seal. And then on the bottom side of the tool, we'll actually be able to run a wire from, we'll have another screw in the center here. We'll be able to run a wire from the center to one of these screws, and that will make an electrical connection from, let's say, a 5-volt line to a pin that is reading, or an input pin. So then as soon as this makes a connection, we can read on that pin, okay, 5 volts, the tool is now engaged. So that's a big feature that we wanted, was to be able to tell when the tool is engaged. So this actually works amazingly well. From quite the distance away, we can basically just move this over here and it just slides right in. Pretty much no error. It always goes into the correct spots. It never, let me pull it apart here. It never does, well, let's see, it never does anything like, let me just use this other one, like that or this. It always goes right on the center, right where it needs to go. Of course, the orientation here, you know, which is it going to go here or 60 degrees that way, or 60, not more than 60, 120 degrees the other way or the other way, that could be a point of error. But I think it's unlikely that this tool is going to rotate over 60 degrees just by nature when it's hanging out in the tool bay. So I think it's pretty error resistant in that sense. So this works really well. Again, comes right on up. You can see that all of the, let's see here if we can get it to focus, all of the O-rings in there are making a nice connection. So that is, it's that, and also the screws are making contact. So it seems to work pretty well. We're pretty happy with it right now. One feature is that, again, these magnets are removable. We have the O-rings for nice seals. There is no error in that it's going to orient the wrong way. It's mostly going to go in there perfectly because there's no metal here for it to want to misorient, and no extra metal anywhere here for it to misorient. One thing that may be an issue is that the holding strength might be too much, especially for such a lightweight tool. It doesn't exactly need a lot of holding strength to be able to be used, and it might be too heavy for the bot to actually remove, not too heavy, too much magnetic holding strength for the bot to be able to remove the tool when it's then sitting in the bay. So once this is attached on there, it needs to then pull it off to be able to get the tool disengaged. So we'll see, we'll do some testing. A remedy for that though is removing these magnets and then just placing in washers that will match this thickness so that we still get that electrical connection, but it's going to be less magnetic strength. And in case even the washers is too much strength, we can use plastic washers and basically just have a very small amount of metal on this side, just enough to get the tool to engage. Like, these just want to go together. Well, I guess it will go improperly if it's at such an extreme angle, but anytime it's coming from above, it's going to slide in nicely. So we're really happy with this design. Going to throw it up on the bot right now, and we'll give it some testing. Cool.